Before the mid-exam, you learn about this partitioning. So we learn about the underfitting and the overfitting, and there are some ways to avoid the overfitting. In the previous section, you learn about the splitting. You can split into the training data and testing. But some of people, they try to split this data. So if we have the whole data like this one, then 60% will be for the training data. It means you will do the modeling based on this 60%. And then 20% of the data, you will do the validation. And then the 20%, you will do the holdout data. So we call this is the static holdout method. So the training set is the data used to build the candidate model. And then we have the validation set. It is the subset of the data to identify which model may be the most accurate in predicting observation that were not used to build the model. So what I can say this one is, I want to validate if the model is good or not. So the keyword here is we want to predict the observation that were not used to build the model. After we know the result from the validation data, it is used for model evaluation. Then the last one is the testing set or the holdout data. It is to estimate the model effectiveness when applied to the data that have not been used to build or select the model. So we have this one. It is to measure whether the model that we create in this training, it is good or not. So we call this splitting is the static holdout method. We can have another way to avoid the overfitting. We call it the k-fold cross validation. K means any integer number. Okay. Usually K is odd number. You can have 3, 5, 7, but sometimes we can use the even number like 10. Maybe you also have 2. Yeah, it depends how you want to do the cross validation. We got cross validation because let's say we have this data. This is 100% of the data. If you want to make k equals to 5, it means you will split the data into 5. 1, 2, 3, 4, 5. And then the last one, you will use it for the testing set. And the remaining, you will use it for the training set. So we call this is the first iteration or iteration number 1. And then we will do the next, which is the iteration number 2. The iteration number 2 we will check. This is the training set. This is the training set. And then we use this one as the testing set. The iteration number 3, yeah, this is the testing set. The iteration number 4, this is the testing set. The iteration number 5, this is the testing set. The remaining will be the training set. So we will make it in the fair. We call it, this is fairness. So every data can be the testing, and every other data can be the training set. So you can get the error. This is the error 1, or maybe if it is not the error, we can say this is the accuracy. Okay, this is the accuracy 1, or this is the accuracy, this is the accuracy number 2 from the iteration number 2. This is the accuracy number 3. This is the accuracy 4, and this is the accuracy 5. And then you will make the average. So I can check what is the average if every accuracy has been measured in every iteration. Then that accuracy will be used for the performance measure. In some other literatures, they call it as a leave one out cross validation. So we want to leave this one, leave one out. So leave one out, this is leave for the testing and the remaining for the training. Sometimes we can use this one, leave one subject out. Let's say you have, in my research, I'm dealing with the human activity. The human activity means in Gandongja, okay, every person will have different ways to do the activity. For example, I want to check the walking. So every person will have their own style of walking. So if I want to make a model, if I want to make a general model, then I need to make one subject out as the testing and let the other subject as the training. So I can say this one, leave one subject out. For example, I have 100 subject, I have 100 person. So one subject will be used for testing, the remaining 99 as the training. So in this case, one subject as the testing, the remaining for the training. And then the other subject for the testing, the remaining for the training, and so on until n times. Or we can have like at least 1 day out. For example, you have 30 days. In 1 month, we have 30 days. So you want to check the data, the daily data. Then, if we have 1 until 30, you will leave the day number 1, and the day number 2 until 30 will be used for the training. And then next, you will use the day number 2 for the testing, and then day number 1, and then 3 until 30 as the training, and so on. Okay. So the picture will be the same like this one. Or leave one sample out. So the idea is also the same. If you have n data, okay, if you have n data, then you will leave out one sample and let the other sample will be the training. So idea of leaf one or cross validation, it is the same with the k-fold cross validation. But in the k-fold, we determine the k will be less than n. But if the k equals to n, it means we will do for every sample. So there will be the same with the leaf one sample. Okay. So I think I don't need to discuss this one because you already have your exam, the accuracy, precision, recall, at one score. So if you check on the formula, I think you can just measure them at one score. For the basic model evaluation, how many data sets do we need to use? We need to use at least 2 data sets, which is training and testing. Okay, so this is the basic model evaluation. There are 2 types of partitioning. What are they? Explain briefly. So we have the static holdout method, and then we have the k-fold cross validation. The static holdout method means we want to partition the data into training, validation, and holdout or testing. Most probably, we can say that the training is 60%, the validation is 20%, and the holdout is 20%. Okay. What about the k-fold cross validation? We want to partition the data into k parts and choose one part as the testing and the remaining as the training. So maybe this is the brief explanation or the short explanation. K parts, we can say the fold. Fold means, as we know before, we make the integer k. If it is 5, then we will divide into 5 fractions. So if we have this data and k equals to 5, then we will split 1, 2, 3, 4, 5, like this one. It depends on the number of k that you want to use. Okay. Okay, now let's deal with the orange. So today, I guess we will deal many things with orange, and I will also give you an example with Python. Okay, so we will play with coding. You can use the data that I give you here, the basic classification. Oh, okay. I give also the later we will check this orange file, and then basic classification 1, basic classification 1 extension, the classification 2. Oh, okay. I already have this one. If you have your file, let's say your file is CSV, yeah, you can use CSV file import, or you can just use file. So it's up to you. If you use CSV file import, okay, let me check the basic classification one. So in the import function, yeah, you need to define what is the cell delimiter, what is the separator. If it is comma, okay, if it is correct, then you will get the column. Okay? If you change this one to tab, for example, then it will not change the data because the delimiter, means the separator. So if the separator is different, then your data will not be in the good column. So you need to make sure that you need to select the cell delimiter correctly. If you use semicolon, okay, this is also not correct. If you use space, yeah, it is also not correct. So the correct one is the comma. And then, yeah, you can define the code character. And then if you have the number separator, you can make the definition. Okay. And especially if your data is in Korean, you can select this using different Unicode. So here you can see there's a Korean Unicode. Maybe, yeah, I'm not sure about your data set that you're going to use for your team project. But if Orange cannot read your Korean character, I think you need to use this Korean Unicode character. But as far as I know, there is no issue if you use file. So if you use file, yeah, the idea is still the same. Okay, the file widget can detect all the columns by using the comma. Okay, let me just use the file. So the first you need to check your data. In this case, I will use the data label. And okay, this data is the same with the example in the PowerPoint. We have the age, we have the income, and then we have the status, whether the person is a student or not. And then we have the credit rating of the student, we have the credit rating of the person. And I give two additional columns, okay? Balance and spending, which is not in the example in the PowerPoint. So the target is still the same, buys computer. So I want to check whether the person will buy computer or not. So in this example, the basic classification 01, you first can select the column and then choose the tree and then create the tree viewer. So first, I need to select column. If you already define everything in the file, then there will be no issue. For example, this one, you know the role. The role is feature, target, meta, or skip. So it means if it is feature, it is the X or the variable that can explain the response. If you put this as the target, it means this is the response or this is the decision. Okay. If you do not want to modify anything, you can modify it in the select columns. In the select columns, again, you can see we have features, we have target, and we have meta. In this case, if I know that the target is by computer, so I can change this into the target. Okay. And okay, let me just skip this one first. Let me remove the numerical column. So you can select what attributes that you want to use. If you think that I just want to use the categorical columns, the numerical column, I will not use it. So you can put those attributes in the ignore section. Okay, so if you already know that this is the features that you're going to use, then you can select the tree. So in the tree, there are some parameters. Whether I want to induce binary tree. You know what is binary tree? We have the two branches, okay, left and right, binary. So it means 0 and 1. And if you unselect this one, it means you will use many branches. If you still remember, when we learn about the okay, if you still remember this partitioning scenario, if you have a lot of categorical data, it means all the branches will appear. Low, medium, high. All branches will appear. But if you select only the binary tree, then there will be only two branches. So it is the same with this parameter. If you choose binary tree, then there will be only two branches for the categorical data. Here, minimum number of instances in leaf. If you join the data structure and algorithm, you will know that for every tree, we have leaf. What is the leaf? Leaf is the most bottom. The most bottom. It means the leaf, there will be no other branch. We want to check the minimum number of instance equals to 2. So it means it is very low. You can change this one, but this is the default from Orange. Do not split subsets smaller than 5. So if it's already like 5, then it will not be splitted anymore. And then this one, limit the maximum depth to 100. So we can have the 3 depth. Okay, the depth, the maximum here is 100. Yeah, this one is still okay. And then stop when the majority reaches 95%. So after this one, maybe it's better to make the 3 fewer. You can check the 3 fewer. So this is the 3. And you can see, yes is the dominant data. We have 9 from 14 data. Okay, so based on the example in the PowerPoint, we already calculated. 9 of the data we have yes. Yes means they by computer. So it means 64.3% from the data they are buying computer. So based on this decision tree, the most important attribute is age. And we will check the attribute. This is the splitting condition. This is the splitting condition. If the age is 31 until 40, then we can see the decision yes, and there are 4 data. Among 4 data, they are yes. So it means 100%. So you can see here, stop when it reaches at least 95%. So it is already 100%. Then there will be no more split. You can see the next, if the condition is less than equal 30 or higher than 40, so we will go to this section. But in this section, we have 50%. So 5 among 10, the answer is no. So it means there is another 5 which is yes. So 5 no, 5 yes. We can make another split because the percentage is still 50%. And then we can see that the most important attribute next is the student, the status of the student. If the person is not a student, we go to the left. If the status of the person is a student, then we go to this one. And then check again. We have the percentage 80%. 4 among 5, it is yes. And then 4 among 5, the answer is no. And based on the parameters, okay, if this still 80% and the minimum number of the node is still 5, so we can still split. That's why they split. So the next attribute that is selected is age, and then if it is less than 30, the answer is no. Now it is already 100%, and the data is 3. If the person age is higher than 40, it goes to here, and then we have 1 among 2, and the answer is no. So I guess the other is yes. Okay. Because we have only 2 left, then we cannot split anymore. This one same, this one the same, because we have already the yes, okay, we cannot split anymore. What about this? Because the data already minimum 2, then we cannot split anymore. So this is the final decision tree. Okay. We can do the confusion matrix and the test score. So we can make the test score, and we can put the data into this test score. Because I do not use the training and the testing data, let's just use the cross validation. So in the cross validation, we can select what is the number of poles. In this case, we can select 2 or 3, 5, 10, and 20. And then there is the word stratify. What is stratify? Just to remember. We learn the stratify in the sampling. In the one of the sampling method is the stratify sampling. If it is the stratify sampling, means we want to select the data, the sampling the data will be based on the label. So the cross validation, the number of folds equals to 5, will be based on the label. They want to distribute equally on the label for 5 sections. And you can see the measure. So we use this CA. CA means the classification accuracy. F1 is the F1 score, precision, and recall. So usually we just use this form, but sometimes you can use also this AUC, the area under ROC curve. I didn't explain the AUC, so you can just use these 4 measures for explaining your model. We can use another way like leave one out. And you can see if it is leave one out, so it means one subject will be the testing, the remaining subject will be the training. So you can see that the classification accuracy is getting high. You can use the random sampling. So you can repeat the train and the test, and then you can set the training set. Maybe this one is the standard 66%, and you can get the classification accuracy as this one. Okay, and you can make the confusion matrix. This confusion matrix yeah, because we have all the data here, they just combine all the data because we have the random sampling for 10 times. So they combine all the 10 times data. Maybe use this one maybe. Yeah, if you use the leave one out, then the number of samples will be 14. And among the 14, yeah, 7 actual is yes, and the predicted is yes. Then the actual is no, the predicted is no, is 3. So you can see this 14. Among 14, 10 of them are correctly classified. 4 of them are not correctly classified. Okay. So if you want to check the data, yeah, you can do the control, click this one, and then you can again check what is the data that are correctly classified. And then you can make some observation. What is the distribution or what is the characteristic of the data that are correctly classified. Okay. Okay, let me stop here. Let's have a break. I will continue after the break.